Brendan here for our final chapter. We have covered a lot of ground, from the technical structure to the governance of automation. But as we close out this journey, we have to talk about the most important part. We are talking about building a practice that It is one thing to write great code, but it is another thing entirely to build an organizational capability that survives change, turnover, and time. Archird is going to help us bring all these principles together into a final blueprint for success. Let us join Archird for the final chapter.
Chapter 11. Capability, not just code. Building a sustainable practice. Automation is a journey, not a product. Success is not measured by the number of scripts you have, but by the number of manual tasks your organization no longer fears. When good code isn't enough. I've reviewed automation programs that possessed impressive technical capabilities, but collapsed within 18 months of deployment. They could set up network segments across 500 switches in minutes. They could generate configurations for complex routing policies automatically. They could connect with a dozen different vendor systems. Yet, they failed. The failure wasn't technical. The code worked, the connections functioned, the performance was acceptable. The failure was structural. These programs had no repeatable processes, no clear ownership model, no succession planning, and no mechanism to evolve as requirements changed. When the original author left the organization, the automation stopped. When business requirements shifted, the system couldn't adapt. When an audit demanded proof of governance, there was none to provide. The technical sophistication was irrelevant because the organizational capability didn't exist. This chapter brings together the architectural principles from throughout this book into a blueprint for building automation programs that survive organizational change, regulatory scrutiny, and the inevitable departure of their creators. If you finish this chapter still believing that automation is a technical challenge rather than an organizational transformation, you will build systems that eventually fail. The 5 foundations of lasting automation. A resilient enterprise network automation capability rests on 5 foundations. These are load-bearing structures. Remove any one, and the entire system eventually collapses under the weight of organizational complexity. 1. Architecture before tooling. The most common mistake is tool-driven design, selecting a product and then designing processes around its specific features. This produces systems locked to one vendor that are impossible to replace when the tool inevitably fails or is discontinued. The correct sequence is to define your architectural layers, establish governance boundaries, and specify your integration points first. Only then should you select execution engines that fit that architecture. When your chosen tool reaches end of life, your architecture protects you from having to rebuild your entire business logic. 2. Testing in reality. Code that hasn't been tested in a production equivalent environment doesn't belong in production. This requires physical and logical separation of environments, sandbox, staging, and production, accurate simulation of production topology, and a sequential progression where no shortcuts are allowed. Your test results are meaningless if your staging environment doesn't reflect the messy reality of legacy hardware and software versions found in your real network. 3. Security as code. Policy documents don't enforce security. Code enforces security. This means moving to policy as code, where policy regulations become automated validation checks, and regulatory frameworks like SOC become architectural constraints. When an auditor asks how you ensure compliance, you don't show a policy document. You show the code and the immutable test results proving it works every single time. 4. Connecting to the business. Automation that doesn't connect to operational systems is shadow IT. It must speak the language of the organization by connecting to change management, ITSM, monitoring platforms, and asset databases. This connection ensures that every automated change is authorized, visible, and recorded in the official systems of record. 5. Surviving staff turnover. The bus factor is the number of people who would need to be hit by a bus before a project becomes unmaintainable. For many automation projects, that number is 1. Lasting automation requires documentation that explains the why behind decisions, code that is readable by others, and team ownership, where at least 3 people are familiar with the system. Knowledge concentration is organizational fragility. The cultural shift. The hardest part of building lasting automation is the mindset shift required from the entire organization. For engineers, you must move from configuring equipment to designing the systems that configure equipment. For managers, success is no longer measured by how many tickets we closed, but by how many manual tasks your organization no longer fears. For organizations, networking must move from a reactive cost center to a programmable asset that enables business agility. The regulatory reality. In the context of the Security of Critical Infrastructure Act, manual network management is increasingly seen as a regulatory risk. Regulators expect traceability, provable access, and automated compliance. Automation is the only viable path to compliance in modern critical infrastructure, but it must be done with architectural discipline. An unprovable system is, from a regulatory perspective, a failed system. The core principles of this book. These principles form the foundation of enterprise network automation. They're not negotiable in regulated, high-stakes environments. Architecture trumps tooling. Design the layers and connections first. Select execution engines second. Tools implement architecture. They don't define it. Version control is the source of intent. If it's not in the repository, it didn't happen. The repository is the authoritative record of what the network should be. Control layer is the enforcement boundary. Use Python to validate, gate, and coordinate every change. The control layer prevents invalid changes from reaching production. Governance is a feature, not a constraint. Auditability is the product of automation. Build traceability, approval verification, and rollback capability into the architecture from the beginning. Safety is the metric. Success is measured by safe-to-fail reliability, not by speed or automation coverage. Trust is built through graceful failure, not perfect execution. If you finish this book believing that automation is primarily a technical challenge, you've missed the fundamental lesson. Automation in critical infrastructure is an organizational capability that must be designed for longevity, governance, and resilience. Build platforms that will outlive their creators. Design architectures that will survive tool migrations. Create capabilities that regulators can audit with confidence. This is enterprise automation.
We have reached the end of our journey through network automation architecture. I hope these chapters have given you a new perspective on how to build systems that are not just fast, but safe, governed, and truly professional. Remember, the goal is to build something that outlives any single tool or person. If you enjoyed this series, please make sure to subscribe and share it with your colleagues. Thank you for listening, and I will see you in the next project.